name is Harav Vladimir Ben Putin, and today I'm here with
Noah.
And I'm going to teach you about regression, linear, quadratic, and cubic. But to get the best experience, we will use calculator in TI-83 series. Now personally, I use 84 plus, but it's still part of the series. So, it's going to be out of control!
First of all, I like to say that TI-83 series calculator much better than N-spire. It's what mathematicians like me use. Now, let's get down to business to defeat the Huns. Linear, quadratic, and cubic regressions are used to take data and produce a best fit graph out of that data in order to show a general trend that the data illustrates. In real-life economics, regressions are widely used for data analysis about a specific product or a trend within a business. In order to make a regression, one must have data to start with, meaning a set of x and y value. The type of regression you choose to take is by means of which type of graph you think will fit the data that you have the most. If you don't know which graph will best fit your data, you can try multiple regression, and the one that fits the best will have an r-squared value closest to 1. The r-squared value is called the coefficient of correlation. The coefficient of correlation measures how close your best fit line is to being completely linear, quadratic, or cubic. The closer it is to 1, the better the fit it is, with 0 being no correlation and -1 being total negative correlation.
Before we start looking at data for regression, we must set up our calculator for coefficient of correlation optimal usage. What this actually means is we will go to the on button to turn calculator on. We will go to the second button at the top left corner. Then we will click 0 down here. Now we are going to scroll down for a long time. So I'm going to say Maria Sharapova while we do this. Maria Sharapova, Maria Sharapova, Maria Sharapova. Now we click diagnostic on. Enter, enter. Done. You'll never have to do it again. Clear. And da. So first we start with data for linear regression. US paging subscribers from 1996 to 1999. Now we are going to show how to do it on calculator TI-84 plus. We turn calculator on first. Then we are going to go to the stat button. Then we are going to go to edit. Press enter. Now, for list 1, we will enter our x values. 1996, 1997, 1998, 1999. And in list 2, we enter our y values. 42 in the millions, 48 in the millions, 53 in the millions, and 59 in the millions. Now we are going to find out how to get our equation. So we are going to go back to the stat button. Click it. Move the right arrow to calc. And now we are going to scroll down until we see linreg, ax plus b. Click enter on that. But don't click enter again. First, click the vars button. Then we are going to scroll right to y vars. On the function, press enter. Then press enter again. And this will give us our equation. The y equals ax plus b equation. Now the a, which is 5.6, represents the slope. And the b, which is negative 1135.5, represents our y-intercept, and our y squared is 0.998726146, and that number represents how close our data is to being a perfect regression. So as you can see, it is very close. Now, to get our scatter plot and the actual regression, we will go to the y equals button. But we will start by pressing second, then go to the y equals button. We're going to put plot 1 on. Click on over here and make sure over here you have list 1 and list 2 as marked before. So now we're going to get out of that mode by going second, quit. Then we are going to go to zoom up here. Then we are going to scroll down until we see the zoom stat. We click enter on the zoom stat and we get our scatter plot and our regression best fit line on top of that. Congratulations, you have done a linear regression. Toda. Now, for quadratic regression, we do data from coca cultivation in Colombia from 1995 to 1999. Now, almost exact same process. So let's get down to the calculator, TI-84 Plus. So let's turn on. Let's go back to stat. Then we go to edit again, enter. Then let's head to our L1 and enter our X values again. 1995, 1996, 1997, 1998, and 1999. Now, Y values in L2. 129, 163, 199, 250, and 301. Now, we go back to stat button, move to the right to calc, then here is the difference. Instead of linreg, we go down to quadratic for quadratic regression. Enter. Now don't press it again. We go back to vars. We go right to y vars. Function. Enter. y1. Enter. Enter again. Now we get our y equals ax squared plus bx plus c equation with a value 3.5, b value minus 13935.9, and our y-intercept as c 13872.162.2, and our r squared as 0.999. You get it. Very close value to perfect graph. Now we're going to get the scatter plot and regression graph. Now we go to second, y equals, we're going to plot 1, enter, on. Now we're going to second, quit. Now we go to zoom again and go down to zoom stat again. We click enter, and there we go, our beautiful quadratic regression. Toda raba. Da. For cubic data, I find data number of young people killed by gunfire under age 20. No, I wish I could find less sinister data, but this is all I had online. So, now we go to calculator. We click the on button to turn the calculator on. Then we go through same process. Stat. Edit, enter. L1, we list our X values. 1992. 1993, 1994, 1995, 1996, 1997. Now that's our X values. Now we go to L2 for Y value. 5.2, 5.7, 5.8. Now we go down. 5.1, 4.5. And lastly 4.2. Now we go back to Stat button. Click Write to Calc. Then instead we go down to number 6 cubic reg. Enter. Now don't press enter button. Vars. Y vars. Function enter. Y1 enter. Enter. Now we have data for cubic reg, and the y equals ax squared, ax cubed plus bx squared plus cx plus d. Our a value 0.057407, b minus 343.6186508, c 685589, d negative 45596 blah blah blah, and r squared value of 0.9858, so very close to perfect cubic regression. Okay, now we're going to see scatter plot and actual regression. So we're going to go to the second button, click, then up to the y for the stat plot. We're going to press enter for plot 1. Going to turn it on, enter. Make sure L1 and L2 are your X and Y list. Now we're going to go to second and quit out of this. Now we're going to go to the zoom button. Then we go all the way down to zoom stat. Enter. And look at this beautiful thing we have here. Da. Yeah.
Yes,